Hi everyone. So finally I'm back on my YouTube channel. Before the GATE 2022 examination, just I wanted to talk about some of the important topic, which belongs to mathematics. As we know that engineering mathematics plays an important role in GATE 2022 to get decided the rank, right? So in this session, I'm just going to talk about the complex variable, okay, and we will take you through a quick revision of this topic. Hope you might have studied already. You might have covered engineering mathematics, from my YouTube channel only. Though I was unable to continue my lecture on my YouTube channel, okay. But now, before the GATE 2022 examination, as we have few days in hand, right? In fact, the admit card is also late, okay. So guys, if you will be live, so you can hit the like button and share among everyone, right? And my voice is on. Yeah, perfect. The voice and everything is good. And so let us start talking about the direct complex variable. Complex variable plays an important role in engineering maths, right? Complex variable. Okay, so I'm just going to talk, in fact, touch all the topics, because it is very likely that definitely 2 mark question will be there from this topic, or you can expect 4 marks as well, right? So, yeah, then moving forward, we will understand what is analytic function, what is CR equation, okay, how we can prove that given, complex function is a analytic or not. All those things we are going to entertain, and we will talk about Cauchy integral formula, we will talk about Cauchy integral theorem, we will talk about residue and all, right? So hopefully my voice and number, right? So basically complex number is nothing but we always write complex number in the form of z, right? So a complex number, say z, right, can be written as z is equal to a plus I b format, right? So as we are engineers, so we have been facing this kind of a number a plus iota b right here. So any complex number can be written as in the form of z equal to a plus iota b, right? Or equivalently you can say that, or you can write a plus b iota, you can write, right? Here a and b are the real numbers, so you can say in this format, right, where z is equal to what, a plus bi, okay. Right. So here the real number a and b are called the real, right? So you have to keep in mind the real number a and b are called what, real, okay. These numbers are called real, okay, real part of this z. And this iota b, okay, iota b, this is called what, this a is called what, this a is called the real part, okay. And this a is called the real part, and this iota b is called the imaginary part of z, right? So you have to keep this in mind. So these are the two important concepts, okay, real part and imaginary part any complex number will be having. Now we must know that okay, as we know that the real numbers are denoted by r like this, okay, if we consider this in the space, right? And the set of complex numbers are denoted by c, set of complex number, okay, all complex number. So these are very basic things, just I'm trying to revise, okay. So hopefully everything is okay till here, and the speed and everything is fine. So let me check as well if my voice and all, yeah, right. Set of all complex number is denoted by c, right? Set of all complex number, right? Here you have to write number, okay. So we can rub this off, yeah. Now we must also understand that how we can locate any point in a plane, right? So suppose this is a plane, just I'm going to consider 2D plane here. right? So this is a plane which is the real axis, okay, we call it real axis, and this is the imaginary axis here, right? So any point in a plane, right? So how your point is represented in a plane, right? In a plane like this, okay, we'll take it like a jet plane, okay. So real axis and the imaginary axis, or you can call it this is x and this is y. Any if you go to the distance from the origin, right, a, okay, so if you're going a distance here, okay, on the real axis, and if you're going b distance on the image, yeah, if you're moving along the x-axis, then what we can say? So you can say that this point, this vector can be written as what? A iota cap, I cap, right? Because this I will be what? This I will be the unit vector, right? And if you're going along the y-axis, so you can write this is vj cap, right? So this is what the vector here is. This vector, okay, this is a vector. This vector can be represented by a I cap plus bj cap, right? A I cap plus bj cap, okay. So this is how you can make the parallel, how we can represent point in a plane, and how we can represent axis. That's it. This is the difference, right? Okay, so z can be written as a plus iota b, right? So this is how we can represent any complex number. Okay, so let's make the revision very quickly. Okay, we need not to spend much time here because everyone understand, right? So if I talk about some arithmetic on the complex number, right, as we know already that we are familiar with the arithmetic on complex real numbers. So arithmetics, they are the very basic. I'm just discussing, arithmetic on complex number, right? Complex number. Okay. So the first one is equality, right? First one is equality. Okay, equality. So when you can say that two complex numbers are same, right? You can say that a plus iota b is equal to c plus iota d, you can say. So when they are going to exactly equal, okay, exactly equal will be there when a equal to b, the real part of a plus iota b, this number, okay, this is a complex number 1 and this is a complex number 2, right? So when we can say that they are exactly same, when a and c are same, okay, and when b and d are same, right? Okay, so this is how we make the parallel here. So b equal to d, so exactly equal, right? Exactly equal, equality proves here, right? And we can also see some of the arithmetic like addition, okay, addition of complex number, how to add two numbers, right? How to add two complex numbers. So right, yeah, so addition of two numbers, how can we add? A plus iota b and plus c plus iota d, right? So you again you can add real part and the imaginary part separately. So just add a and c first and then iota b and iota d, right? So part wise addition can be done here, okay, component wise addition or part wise addition. So a plus c you can put in one bracket and iota common here and b plus d, right? So when you are adding two complex numbers, you are getting again the complex number, right? Okay, so in this manner you can understand these are not that difficult topics, just I'm making a quick revision for you, okay? Sometimes in the examination you might make mistake, okay, but you have to keep this in mind. Okay, now let's talk about multiplication here, right? Okay, multiplication. So in our school days, we have done multiplication of among real numbers, right? 2 into 2, 4 into 4, 5 into 6. Some in this kind of multiplication we have done, but we haven't seen the multiplication or in higher secondary school we might have seen multiplication, while preparing for IIT JEE and all. So we can make a quick revision how to multiply two complex number. Okay, so how to multiply two complex number? Just like this: a plus iota b multiplied by c plus iota d, right? So again you can multiply a into c first, right? So a into c plus iota a into d plus, okay, then you can make the group of real part and the imaginary part, right? So c iota c b, okay, and then minus, okay, minus b into d, right? Because you will get iota square, and we know that iota square is -1 here, right? Now what you can do here is you can put ac plus minus bd, okay, and you can take common iota ad plus cb, right? So this is how we multiply the two complex number, right? This is how we multiply two complex number. I hope this is clear for everyone. I hope this is clear for everyone, right? Okay, so let's go ahead, okay, for future discussion, right? So let's talk about conjugate, complex conjugate, right? This is also very important, complex conjugate. Okay, just I'm making revision here. So what is complex conjugate? Basically, if any complex number is given, and if you're going to take the complex conjugate of that, so the complex conjugate of z is equal to a plus iota b, is defined as z bar, you can say, or z star, whatever you want to call it. So if you're going to take the conjugate of this a plus iota b, so real part is going to be same, but this imaginary part will be changing its sign, so it will be iota b minus iota b, right? So this will be known as the complex conjugate of z, right? So if z is given, so its complex conjugate is going to be z bar, or you can say z star. In signal and system, in everywhere, one must know what is complex conjugate. In fact, in network analysis, okay, this kind of a question comes, okay, when we discuss complex power, right? Complex power, right? So in that complex power, you might have seen S equal to V times I conjugate, okay? Sometimes you might have seen, so you get confused, okay, why we take this conjugate and all, right? So this is what the important concept, right? Is what is complex conjugate? You have to just change the sign of that, okay. So I hope this is clear for everyone. Now we will talk about like we have introduced the complex conjugate, okay, because this is the another important part here, right, to be discussed, right? The complex conjugate of this z equal to a plus iota b, and the number a plus iota b is defined as the conjugate, means this I will be what? This I. This I will be replaced by minus I, that's it, okay? So you can see this I is replaced by minus I. So it means that we have the complex conjugate, okay, a minus iota b, okay, this is the complex conjugate of a plus iota b, right? So this we call it complex conjugate. Now we will talk about okay, now we will talk about what are the modulus and the argument of the complex number, right? So what is the modulus and the argument? This is also very important, modulus and the argument of any complex number, okay. These are very basic things you must know before you get into complex variable, right? Okay, so I hope till here it is clear. So every day you will find some lecture on maths now before GATE 2022 will be conducted, okay. So let's talk about modulus and the argument, okay. So as we have seen that any complex number can be represented on a plane. So this is x-axis and this is y-axis, right, and any point is here, right? So if we draw the perpendicular from this point on x-axis, okay, and this is x here and this is y here, right? This point can be represented by x iota by x plus iota by, right? So from the origin, if we are going to join this, so this will be r, right? So the number r is called the modulus of the complex number, right? The number r, this number r, okay, this number r is called, okay, this number r is called the modulus of the complex number, right? Complex number z equal to x plus iota by, right? Okay, this r will be known as this r, right? This r will be known as what? The modulus of, okay, the modulus of the complex number z equal to iota by, okay. You have to keep this in mind. So here, you know, modulus of, you know, x plus iota by, if we are going to take the mod of this, so this can be written as x square plus by square, right? The real part is square plus by, okay. It follows basically the Pythagoras theorem, right? So from here to here the distance is x, from here to here the perpendicular distance is by, okay. And okay, from this point you have drawn the perpendicular on y-axis and x-axis, right? So you can think of like this right angle triangle, right? So this theta is there, okay. So we can directly write this r is equal to under root x square plus y square, right? Okay, so you have to keep in mind this is known as the modulus, okay. This is origin, right? Okay, and the angle theta is called the argument of z, right? And the angle okay, angle theta is known as what? Known as the argument of the z, right? Argument of the complex number g, right? So you can find directly that the theta is basically the arg of g, right? We write like this, okay. And how to find theta? Theta will be, you can calculate theta directly here, you know this and you know this, right? So just based upon you know, you can write directly in terms of tan theta. So tan theta is going to be what? The by the perpendicular, that is by upon x, right? Okay, so this is tan theta, okay. And you can take the infinite value of theta, right? You can take the infinite value of theta, okay, the one which lies in minus pi, okay. Theta you have to choose, okay, in such a manner that this theta value will be infinitely, okay, any value you can take infinitely, okay, infinitely many value of theta, right? Okay, among infinitely many value of theta, okay, the one which lies between minus pi and pi is called the principal value, right? Which lies between minus pi and pi, okay, is called the principal value, okay. This kind of question also has been asked in the examination. Principal value, okay, r of g, right? So this is very important because everyone knows that tan theta is equal to pi by x, okay. Okay guys, I hope this is clear for everyone, right? So there you can pick up any value for this theta, but if the theta belongs to this interval, right, minus pi to pi, okay, minus pi to pi, then it is called the principal value. That's it. That theta value will be called as the principal value of that, right? So I hope this is clear for everyone. Among all the infinitely possible values, if one lies between minus pi to pi, so we will call that value as the principal value of the argument z, right? Okay, now let us talk about the polar form of the complex number. Okay, as we have understood the basics, that is what is the modulus of any complex number, what is argument of the complex number. So now it's time to come up with the polar form, right? The polar form of complex number. Okay, complex number. Okay, so what is polar form basically? So in polar form, basically we have to note that, you know, like we have seen this plane here, this point was represented, and this was the modulus, right? And this is the argument of g. Okay, this is x plus iota by, okay, and this is by, and this is x. Okay, so from here you can calculate x equal to r cos theta, right? And you can also calculate by equal to r sin theta, right? So x and y are the Cartesian coordinate system. You know, you might have studied these things in the coordinate systems, right? So if this is x and this is y, okay, so if you are converting you know, from x to y, if you're going, okay, so right, so you can see here, just I'm telling you, so any z equal to x plus iota by any complex number, right, can be written you know, in the polar format, right? So this z can be written as what now? See, z equal to what? X plus iota by. So as we know that x equal to what? R cos theta, right? Where r is the where r is what? The modulus, okay, and the theta is the argument of g, right? G means this is a complex number, so this g can be written as r cos theta. Okay, you can replace x with r cos theta, and y can be replaced by r sin theta, right? So this is what the uh, you know, polar format here. So we will see, okay, we will see okay, this is basically in the trigonometric format, you can say, right? This is in the trigonometric format, right? Where r you can take common, so cos theta plus iota sin theta, right? This format is, you sometimes people call it rectangular format, or you can also call it trigonometric format, right? Trigonometric format, okay, or form. But from the Euler relation, you know that you can write, or exponential format, you can express this cos theta plus iota sin theta can be written as e raised to power iota theta, right? E raised to power I theta, right? So this can be written as e raised to power I theta, and this is what the polar form. Okay, any complex number can be written in the polar form like this. Okay, and what is r here? R can be calculated directly just by taking the modulus of that complex number, and theta can be calculated by x, right? So this is the polar form, okay, or you can say the exponential form. Sometimes people call it exponential form. Okay, in different books you will find this, right? So what is polar form? What is okay guys, so you have to understand these things, right? Okay, so polar form or exponential form, right? How to convert any complex number from like x plus iota by form is given, so you have to go to represent in the polar format of the complex number. So this is how we write it, right? Okay, so let us see some of the properties of the complex number. Okay, because in aptitude we always see real numbers and we talk about real number, you know, we talk about different kind of properties over there, but we don't get an opportunity to discuss about the properties of the complex number anywhere besides in the complex variable class, right? So let's talk about some of the properties, some of the very important property. In the gate examination they directly ask question from the properties, okay, some properties of complex number, right? Or these are the parts, you know, these are some parts, okay, and they can be given as whole, right? So if any question is being framed, so they can pick up these parts and they can put these parts into the question. So if you are not good in parts, so how can you handle whole, right? how can you handle the question itself? So many people they always look for the formula, right? So in the gate examination, it does not happen always that you know uh, if you know the formula you would be able to solve the question. No, if you are good at basics, then only you would be able to solve the question, right? So guys, remember always this. Okay, so that's why I'm conducting class on maths, and most of the aspirant, admit their difficulty levels. Why? Because they do not touch mathematics in entire course of their preparation, right? They always try to confine themselves, preparing maths before 7 days of the examination. So that is very bad practice, right? I always recommend for every gate aspirant, as they start any technical subject, before that they must also start mathematics. So in total, in parallel you must study maths and you must study any topic. You must know what are the mathematics topic, required to to understand any technical subject, right? Chalo, theek hai. So let's talk about complex, some of the property of the complex number. So the very first is, like, if you're going to take any complex number z and take the conjugate of this, so what is going to be equal then, right? So it will be equal as the mod square, right? This you have to keep in mind, right? Any complex number you take and you take the conjugate of that, right? You take the conjugate of that and take the product, so you will get the modulus of the square, okay, or square of the modulus, you can say, right? So you can prove here, okay, just I'm trying to prove here, okay, for you. Suppose z is given as a plus iota b. What is going to be the complex conjugate? Z bar a minus iota b. Just you have to replace this I with minus I. Now what you can do here, just take the product here, right? So you know the multiplication. I have shown you that how to multiply how to multiply two complex number. So you can multiply these now. So a square, right? A square, okay, so this can be written like this is a plus b and a minus b kind of a concept right here. So this is x plus y and x minus y. So what is this? This is x square plus y square. You can write this is iota b whole square, right? This is minus here, this must be minus. So a square plus b square will be, because iota square is gonna be -1, right? So this is how we can prove that yes, this is correct, because the z is a plus iota b, and what is the modulus of z is basically a square plus b square, and what is the square of the modulus? That is a square plus b square. So this is how you can prove any identity, any kind of property of the complex number, right? So this is very, very important. This is how we solve the question, right? So to make yourself confident, you must know how to prove anything, right? This is one part, one property, right? Okay, let's take a look on second property, right? So the second property says here is that any modulus, okay, any modulus of z, mod of z, if it is given as 0, right? So it can also be written as z equal to 0, okay, remember, okay, this is very, very important, okay, or vice versa. You can say that if modulus is equal to 0, mod of z is equal to 0, so z you can write directly as the z is equal to 0, okay. This is very, very important. This is brilliant, right? This property is very, very important. It looks very easy, right? But it is very important. You can directly say that if z equal to 0 means x equal to 0 and y equal to 0, okay. Now this is also important. If you're taking the modulus of z, and if you're taking the modulus of conjugate, both are same. This is again the fourth property of the complex number, right? I'm just making the revision for you all, okay, so please note of it, right? This might help you, or you might not have seen this kind of lectures, right? So if you're going to add two complex number, right, and take the conjugate of this, so you can express this as individual, you can express as sum of the conjugate of the individual complex number, right? This is the magic here, right? It is one important property of the complex number, right? So you can prove here if you want to prove. I'm not going to prove. You can take Z1 as a plus iota b, and you can take Z2 as c plus iota d, and you can prove. Okay, so if you're going to add them and then take the conjugate, or you can take the conjugate and add them, both will be same. So I hope you would be able to solve this, right? So this is again very, very important, right? So these are the some elementary properties of the complex number. Okay, so you can prove, okay, these things. These are very important properties, right? And the next property again I'm just going to bring here is that if you take the product, okay, and take the mod of that, right, modulus of that, so you can take the modulus of individuals as well and take the product. This also holds true. Okay, so take two numbers, multiply them, take the modulus. Take one number, take the modulus. Take second number, complex number I'm talking. If I'm saying number, because we are in the complex variable class, so you have to always consider that the sir is saying the complex number, right? So take the individual product and then you will find that, yeah, again there is a similarity, right? Equality holds. And one of the very important is property next is that if you're taking the arg of product of Z1 and Z2, right? So you can add arguments. Okay, this is also very important. Sometimes in the options they will give you these kind of properties and you have to pick up, okay, what are the options correct, right? So you get panic. Oh, which formula we have to apply? No, just consider yourself any number 3 plus I 4, take the conjugate, multiply them, see whether these equality holds or not, right? Understand? So whenever I teach in the class, I always emphasize that in this manner one must study, right? One must not go behind the formula and at the end or before 7 days of the examination become panic. Okay, so this is argument, right? So these are very, very important concept which I wanted to highlight, right? So let us talk about one of the very important property again. If you're going to take the power of any complex number is there and you're taking the power of n, so this can be written as r to the power n, right, cos n theta plus iota, cos n theta iota sine, okay, iota sine n theta. This is also very, very important property, right? This is one of the very important property. If you're going to take the power and nth power, right, of any complex number, so r to the power n will be there and these arguments will be changed, right? So they will be the multiple of n theta plus iota sine n theta, right? Next property is, I'm not going to prove again, you can prove if you want, right? So if you're going to take the modulus of this, so you will get the modulus of, okay, this, okay. So if you take the power nth power of g and take the modulus, or if you take the mod of g and take the power, right, both will be same. This is also one important property. And if you are having arg of g and taking the nth power, right, so you can write this as n arg of g, right, n arg of g, right, n arg of g, okay, n arg of g. So this is also important concept, right? So these are the important thing people mostly skip in the class, what I want to highlight here, right? So because sometimes 1 mark or 2 mark you can directly get, right? And nowadays in the gate examination, conceptual questions are expected, right? So you must know all these things, guys. Okay, ठीक है. Let's go ahead and talk more property. Okay, if they are there, right? Okay, right. So yes. So next property here is if you're going to take the ratio of Z1 and Z2, okay, and so you can split them. Okay, take the ratio of Z1 and Z2 individually, take the modulus, and okay, this can be also proven. Okay, so take the ratio of Z1 and Z2, take the modulus, right? Or equivalently, you can say take any complex number, take the modulus, then divide by, take other complex number and take the modulus. Okay, same will be. And in case of argument, so arg of Z1 and Z2 can be written as arg of Z1 minus arg of Z2. Okay, this is how we write. Okay, you can prove these things. So please keep these things in mind, before you get into complex variable, right? So this is the basics of complex variable, what I wanted to discuss. Okay, so before I started before I start talking about the neighborhood of a point, because in the next lecture we are going to start the neighborhood of the point, because we have to start the complex function, we have to talk about complex variable and all. So in this session this will be enough. I will again conduct after this session about the neighborhood of a point. Okay, so I hope you might have now understood the basics of the complex number, right? Thank you so much. We will meet in the next session. Thanks.